This review help video is for Standard 5 systems of linear inequalities. So we're going to graph the first one. Zoom out just a little bit here. So on this first equation, y is less than or equal to 4. At 4, I'm going to just draw this line. It's a solid line because it's equal to, and I want all the y's that are less than it. On the next equation, y is less than or equal to -3/2 x minus 2. So at -2, plot a point, I'm going to go up 3 over 2. And I'm going to plot that line as best I can. So with this, once again, sketching as best I can. I want all the y's less than this line. So all the y's less than this line. And then the last equation that I have here is going to be a dashed line. Solving for y, I'm going to get y is greater than -3x minus 2. So I'm going to go to minus 2 again. So my slope is minus 3. So if I go up 3, I'm going to go left, up 3 left, down 3. And this is a dashed line. And then I want all the y's bigger than it, so that'd be to the right. Vertices, I have a vertex here, which is at 0, -2. I do have a vertex here. It is not a vertex in my feasible region, but it is a vertex. That's at -2, 4. And then I do have vertex here that's at 4, 4. My shaded region, so my green is over here. My blue is going down here, my purple's here. So my actual solution of my shaded region is not a typical triangle. It's actually down here. And then the only solution of those vertices that would be for this graph is 4, 4. So my only solution would be 4, 4. Because it's the only one that makes the inequalities all true. Because it falls within the shaded region. This one here does not, excuse me, it's not a solution because it is on a dashed line. Alright, so this next equation over here, I'll start with this top one here. I will add y over and subtract 3, so I'd have y. If I move it over here, it's going to be less than 2x minus 3. So at -3, my slope is going to be up 2 over 1. And it is a dashed line. So I'm just going to add the dashes in between here. And once all the y's less than that, next equation, graph this bottom one here, plus 4. So I'm going to go up to 4. So actually up to 4, that's 1, 2, 3, 4. And my slope is 3/5, so I'm going to go up 3 over 5, down 3 over 5. That's not 5. There's 5. Down 3 over 5. 1, 2, 3, 4, 5. Up 3. 2, 4, 5. And that is a solid line. And I want all the y's less than that. And last but not least, I have the other equation. I'll solve in green. So I'll minus the 4x over, so I'd have 5y is greater than negative 4x minus 15 divided by 5. I'm going to get y is greater than negative 4/5 x plus 3. So I'm going to add 3. Positive 3 here. I'm going to go down 4. It's a minus 3 Pomeroy. Down 3. There we go. And then 4, 5. Down 4. 1, 2, 3, 4. 1, 2, 3, 4, 5. And that's a dashed line also. Whoops. And I'm going to shade this way. So once again, this is a shaded region. Don't get me wrong, I like giving you the triangles that all worked out, but sometimes solutions that work out are not always triangles. Normally they are, but I wanted you to see situations when you're doing this that come out to not always be the triangles, but you have areas that are partial solutions or solutions that make shaded regions, so you really got to pay attention to what shaded regions are. Excuse me. So I do form triangles, but in this case my shaded region, once again the 3 shaded regions that cross are out here. Normally answers will be a triangle, but not always. And then your vertices, you have one here at 5, 1, negative 5, 1. You have a vertex here that is at 5, 9. And this vertex here that's at 0, negative 3. And none of those are solutions. So the next thing I have for you is writing system of linear inequalities to help solve the story problem. That means all the equations. Then write the equation that models the profit for the story problem. So in this specific problem, we have skateboards and inline skates. So skateboards and inline skates. Okay, I'm going to make inline skates Y, skateboards X. The first equations that you're going to have in these real-world problems is we're either going to put you in constraints with at least or at most certain values, or you're going to be put in with the equations of greater than or equal to 0, so it depends on what the word problem says. So the dealer demands that you make at least 30 skateboards per day, so that means per day you must make at least 30, so greater than or equal to 30. And you make at least 20 pairs of inline skates. So inline skates, you got to make at least 20 per day. The factory can make at most 60 skateboards and 40 pairs of inline skates per day. So that means at most y would be less than or equal to 40. And then x would be less than or equal to 60. The total number of skateboards and inline skates cannot exceed 90. So that means skateboards and inline skates, when added together, cannot be greater than or equal to, or cannot exceed 90. But it means it can be equal to 90. The profit for each skateboard is 12, and the profit for each pair of inline skates is 18. So profit equals two values added together. The price for my inline skates is 18, so 18y, and skateboards is 12x. So that would be your 5 equations plus your profit equation. Alright, this next one here. Store sells 2 types of toys. You have toy A, toy B. The store owner pays $8 and $14 for each unit of toy A and B respectively, meaning B gets the second number, A gets the first number. 1 unit of toys A yields a profit of $2, so A yields 2 for profit. Oh, come on, pens. And then B yields a profit of $3. The store owner estimates that no more than 2,000 toys would be made or sold every month, and he does not plan to invest more than 20,000. So first and foremost, I'm going to let A be X. I'm going to let B be Y. So out of these equations, I got Y is greater than or equal to 0. And X is greater than or equal to 0. Because it doesn't give me any other constraints. So the next one I want to do is I want to look at the money. So he's going to pay $8 per A toy and $14 per B toy. So $8 and then $14 added together is not going to go more than the 20,000. So, and then respectively, he's going to sell no more than 2,000 toys. So these values are going to get added together, and no more is less than or equal to 2,000. And then we have profit. We're going to make some money, so profit equals 2 things added together. Back up here, yield profit is $2 per A toy and $3 per Y toy. Alright, last one here. Bakery is making whole wheat bread and bran apples. So I'm going to let my bread be X. I'm going to let my bran apples be Y. First 2 equations, Y is greater than or equal to 0. And if those have to change, X is going to be greater than or equal to 0. But if not, then they're okay. If they get changed, then they'll get changed. For each batch of bread, they make a $35 profit, and for each batch of muffins, they make a $10 profit. So profit, please excuse my dog. is going to be $35 for bread and $10 for muffins. It's a really bad 10. Alright, so now the bread takes 4 hours to prepare and 1 hour to bake. Muffins take 0.5 hours to prepare and 0.5 hours to bake. Maximum prep time is 16. Whoops, wrong color. Is prep. And bake time is 10. Alright, so I have maximum time allowed is 16. Maximum time allowed is 10. 16 is baking or preparing. So 4 hours to prepare and 1 hour to bake. Respectively, 0.5 hours to prepare, that should be a Y, and 0.5 hours to bake, and those values get added together. Alright, last but not least, equations. System inequalities is graphed below. For each boundary line A, B, and C, identify a symbol, inequality symbol that would produce the given feasible region if they're written in slope-intercept form. Also lists all vertices that are solutions for the systems. First of all, line A is this line right here. So we're going to just do what we've been doing, looking at where the graphs are and everything. So I'm trying to figure out what's going on with this here. Yep, we'll just deal with it. So line A is this dashed line here, and it wants all the values below it. So A is going to be less than. It's not equal to because it's dashed. Line B is right here. It's a dashed line, and here at this Y value of Y, it wants all the numbers bigger than it. So that's going to be greater than. And line C is this solid line, left and lonely one. When it crosses that y-axis, it wants all the y's bigger than it. So that's also going to be greater than, but also equal to. Vertices, these are all open. Dash line, dash line, dash line solid, dash line solid. There are no solutions. Looking at this one over here. So the A line is right here that's dashed at this Y value. It wants all the Y's less than. It is not equal to because it is dashed. Line B and C are both equal to because they are solid lines. B, if you continue this Y all the way up here, eventually it would cross the Y axis. At that time, all the values less than when I cross are going to be shaded. And then C, right here where it crosses, it is greater than, so greater than. And out of my vertices, solid dashed, solid dash, solid solid. My only solution that works is that one right there. And when you cancel that out, that number is 8, negative 10. Last but not least, this one right here. Line A is a solid one right here. So it's going to be equal to. B is solid, that line is right here. It's going to be equal to, and C is dashed. So at C, it wants all the y's that are less than that graph. So that is going to be less than. At B, at this y value, it wants all the y's less than. And at A, at this y value right here, wants all the y's greater than. And the vertices that are solutions, solid dashed, dashed to solid, solid solid is this point right here, which would be negative 4, 1. That's it.